Okay, so I'm going to record the, so students, if you're listening, if anyone's, I'm not sure who's actually listening, but because I probably don't post them timely enough. And also, I'm not sure anyone really wants to listen that closely. I think I post some good notes, so maybe you don't need to. But I did just go over that quiz, reviewing the material and the topics for quiz 3. So make sure you you review that material. Okay, but let's now talk about today's big topic, which is interfaces. So last week we talked about generics. Remember generics? And you have the, I don't see when I go like this, doesn't that tell you what we talked about last time? Remember generics is the diamond operator. Remember you have array list, and after array list you have the greater than or less than sign, and maybe you put string in between. That's the generic, and that's what we talked about last time. And I put those notes online. Now I want to talk about something called interfaces. And first of all, let's just see this. Let me just one example. Let me just share this for a second. Then I'm going to go to the slides, and then we're going to go back to here. Okay, so I didn't share that, did I? Okay. So let's just see an example. The one we're eventually going to talk about something called the comparable interface. So let me just see. I'm going to start a new. Let me just start some new class here. I got a test. I already have a test in there. Let me just do test 2. And I wanted to show we compare objects with this method called compare to. Okay, we don't, and that's actually a method what's defined in the comparable interface. That's what we're going to eventually talk about today. And that'll probably be part of your next programming assignment. Let me just call this test 2 because of use of default packages is discouraged. Oh, well, okay. And this is hello. I should have told them to put the main in for me. Okay, so let's say I have string x is equal to cat. Okay, let's say string y is equal to, now dog is, and notice that they're all lowercase characters. Is that right? What does it, oh, I see. Oh, it still doesn't, oh, that's better. Okay, so, and I have these 2 strings, cat and dog, they're all lowercase. And so I'm gonna see if what happens if I print this out here? Okay, so I guess I could have gone, I'm gonna just go x greater than y. So greater than should return true or false. Like if I compared numbers, like here, if I go like this, and let's say greater than 3, well, that's not a problem because that's going to be true. It's going to display true. But here, x greater than y, what's the error message? It's undefined for strings. So we can't compare. So we can't compare strings with the greater than symbol. But what we could do is this. You have to compare it. There's this compare to, you have to compare it to a number. You have to compare it to 0. X dot compare to y. Do I have enough? X compared to y. We put enough parentheses in there. Okay. System out print line x compared to y. Why doesn't it like me? What does it say? Oh, systems, because I spelled, this is the problem. That's better. Okay, so now this is equivalent. See, it looks kind of clunky, but that is, so when we compare objects, when we're comparing numbers, we use the same operators we use in math, calculus, or algebra. You want to compare objects. What I have there in line 10, that's how we compare objects. This is equivalent to is x is true if x greater than y. And of course, what does it mean for one string to be bigger than another? So, well, that's that's an issue that we're going to be talking about. Okay, basically, the further back you are in the dictionary, the bigger you are, except lowercase is greater than uppercase. Okay, so let's see what happens. So I should get false here. Okay, oh, should be true, false. Yeah, true, false, yeah. Because cat, see, X is cat, and it's saying is cat greater than dog? And no, because the C becomes before D in the dictionary, and all the cases are the same. So okay, but okay, so I'm going to stop sharing this, and now we're going to talk. I do have this interface example we're going to do, and then the thing about the string class, see this compared to string implements. Implements this interface called comparable, and that's our ultimate goal today. How can we write a comparable interface? Because what we're going to learn is that all objects are going to be compared with the same method, compare to. Okay, so we want all our objects, we want the same, because otherwise, oh, let's compare string objects with compare to, let's compare circle objects with something else, and we want the same method name for whenever we compare objects. And we need to do this comparison because what if we want to sort? Or let's say we want, like on Amazon, you go there, you're sorting, right? Maybe by price or by last name. So sorting a list of objects is really not unusual. It's just we just need a criteria on how to, what's bigger than, what does it mean for one object to be bigger than another? Okay, so let me just stop sharing this and just ask any questions. And now otherwise I'm just gonna open up this interface. I'm going to share something else here. This should be online if I can find it. And of course I can't find it. Okay, maybe it's part of this. Let me share this. Maybe it's by tab. Yeah, it's tabbed. Okay. Okay, so you should see, and this is online. You go to I created the module. I know there's a lot of stuff in there, module 3, but somewhere there should be this file called interfaces.pdf. But can you see that? If you don't see interfaces in the middle of your screen, I wrote this last fall. Though I've been pretty much giving the same lecture for a long time. Because there's really not a lot. Interfaces really, it's a relatively straightforward topic. It's just using it in a way that's meaningful is maybe more challenging. Okay, so we're going to know what an interface is. Interface is actually a new keyword. Yeah, interface and implements are two new keywords, meaning we can't use those terms as variable names. And then we're going to learn how to write an interface. And we're going to be users of interfaces more likely than writing one, but I'm going to show you how to write one. And the great thing about interfaces is this whole concept of polymorphism. And then there's we'll talk about the comparable interface. Okay, so interfaces allow us to pose the same behavior in classes that appear to be very different in nature. So like comparing. So I can compare a circle or two circle objects. I can compare two string objects. So a circle and a string, they don't have anything to do with each other. Or I compare like a circle and I can compare people and book. So we can learn, what we're going to do is that's one feature that all objects have in common. We can compare them. Even though the classes themselves are very, very different. Okay. And so interfaces are a way to define the same comparison behavior in all classes. We want to use the same method. That way it will make it a lot easier to write our sorting routines, because in sort you have to order things, right? You have to say which one's bigger than another. You have to do greater than and less than. So okay, so I have this kind of silly interface. So since I'll just say one thing. It's unlikely that we would ever probably write an interface. We're going to be users of interfaces. There's some people who design these class libraries, and then there's some people who use it. It's like some people like design cars, and then most people just drive them. Okay, so we don't know, we can drive a car without actually having to design one. Okay, so if this is something different, so normally in Math 130, what do you always see? In Math 140, public class. So now we see something a little bit different, public interfaces. And so in an interface, all we do is, the rules have gotten more complex, but as far as we're concerned, all the interface does is it defines method headers. And notice how I don't have public in front of, to the left of string, they're implicitly all public. So when you define an interface, all the methods are implicitly public. If you try to make them less than public, like private, you'll get an error. Okay. Okay, so we don't actually implement the method. We just say, okay, this interface defines this method. So that's it. That's you know a lot about interfaces right there. Look at that slide 5, and you're maybe it's like what's this for? Okay, so so we're just defining the method header, and this is the challenging thing about interfaces. Like how can you create an interface that has that's meaningful, that a lot of people will want to agree to use. So actually writing one is easy. I mean, if you don't care about what the point is, like no one's going to want to use my describable interface. Okay. So we want to use interfaces that the whole world will use. So yeah, so the method, yeah, so that's what I'm saying. Methods in an interface are always public. So these two slides, see the one, string describe class. So some real hardcore people say, when you define an interface, you don't put public to the left of string because you write as little code as possible. Some people will say, well, if you write your interface like this, like the one on line page, slide 7, it kind of, oh, you don't know what you're doing. It's kind of like a sign of like, oh, you're not like a top-notch Java programmer because you put public to the left of string. Okay. You should know that that's invisible code. Okay. Okay, so so now is the really exciting part of today's class. No, it grows, students. I could say this is the exciting part, but it's kind of like a roller coaster. So we're like halfway up the roller coaster. And then, okay, yeah, everyone logs off. Okay, so this is really important to understanding interfaces. Do you see that word implements? So now we're used to classes, right? And we say a class implements an interface. What we're promising is to the user of this class, oh, it's going to have all the methods defined in the interface. So remember, you have to remember what was in your interface. It has a method called describe class. So if I say a class implements describable, you're guaranteed to have that describe class method. And you can have other methods too. You can have everything that you would normally have, but you must have. This is an absolute requirement. And if you don't have it, you'll get an error message. It might say your class is abstract, which I don't talk about anymore. Abstract just means there's a method that has, you can label a class, like you can put public class, I can't remember the abstract, I think it's public abstract class. And it means it has methods that haven't been fully filled in. You just have the method name. Okay, so if you say a class implements an interface and you don't actually override, if you don't actually implement the methods describing the interface, someone's going to say, well, you're going to get an error message like your class, you have abstract methods in your class. Okay, so so yeah, so this is what I just said. Yeah, so when you see that implements describable, you have to implement the method describing the interface. So here is a real simple thing. So it says the method's going to return a string. So I just return the name of the class. So now here's the thing that this is kind of describes the important part. Until maybe we see the examples later on in the course, it'll eventually sink in, like a lot of stuff. A lot of stuff in Java did. The whole polymorphism concept took me a while to understand. This is what's the point of an interface? So we could write a describe class method in the test class without using the expression implements describable. Okay, but the reason we do it is because of polymorphism. So yeah, I have a phone call. I'm just gonna, that'd be kind of rude for me there. Okay. Yeah, okay, so what's the point of an interface? Right now, okay, so we could write this class, we could write describe class method without saying implements describable, but it's because of polymorphism. Okay, so now I have this Java application online here. So let me I'm going to stop sharing this and I'm going to share my screen. I'm going to go back to Eclipse. And okay, so I put a bunch of files online. I don't know if you can see it in, that modules. I think if you go into the interface, go to the module, and I have some files for interfaces, and I have a bunch of Java files, S, test, and W, and describable. These four. See, I have this one, describable. That's what we just saw, right? And then I have a class that implements describable. And see, and I have methods in there, but I definitely have this describe class method. So everyone should see that class S right now. And then I have another class W that, see, now I got two different classes that implements describable. Okay, I have two different classes, and they both have a describe class method. And because they implement describable, they're guaranteed to have describe class. And now here comes hopefully comes the, maybe this will help you better understand this. So remember, we have this interface called describable. And this is totally new right here. Do you see right here, so describable is an interface. So normally in a parameter, we would have a class name. But now what we have is an interface name. So we can declare a variable. A variable can be of type, it can be an interface. And so what you do is what kind of data can you assign to that variable that's defined as an interface variable? It has to be from a class. It has to be an object whose underlying class implements describable. But because here, see how in line 3 we say that parameter is of type describable, we're limited to the methods defined in the describable interface. Describable only defines one, if I can find it, describable defines one method, describe class. Okay, so let me go back because I can't find it. Okay, because I have too many files open. Okay, so the one thing we know about this variable D, it's of type describable. It has a describe class method. And now we already started at main, so let's go to main. And the first time we create a W object, and it says, okay, and then we call this display method. So the first time we're going to pass this W object. Now let's look in class W. W implements describable, and its describe class method returns this is class W, and for class S it returns this is class S. So now let's just run this. So this is where the polymorphism comes in. The first time D is going to be a W object, and then we're going to call display a second time. So here, D is a W. See, the code says that D is of type line 3. The code says that D is of type describable, but when the code is actually running, the runtime environment knows the true nature of the object. That's polymorphism, when a variable can change its nature during runtime. So then the second time, D is an S object. Okay. So now let's just run this. And see, that's what happens. That's the advantage of interfaces. I just write one method called display. Its parameter is of type describable. Now I could write another class, have it implement describable, and then I can pass, let's say write a class called T, and it implements describable. And then I can pass a T object to that one method. I wouldn't have to write that method over again. Now that method's kind of not that interesting. It doesn't really do a lot. But that's the advantage of interfaces. We can make them parameters to a method. And so one thing I'll show you later on in the course, we get to the sorting, is now the book actually does all its sorting on integers. So I'm going to expand on that. And first we'll learn how to sort integers, and then I'm going to show you those same algorithms sorting objects. And so if you write a sort method, and its input parameter is an array of type comparable, meaning you can actually compare the objects. Then you can sort that. So as long as that means you could write one method to sort an array of any kind of class whose underlying object implements comparable. Okay, but I'm really jumping ahead of myself. The important thing about interface is that we can, but the important thing about interface is that we can make them a parameter to a method. So, and then so we just write one method, and then we can pass any kind of object whose underlying class implements that interface. So this might be a little bit hard to I would probably find this hard to understand when I was first learning it. But any questions right now before I want to go back? Let's go back to the slides a little bit, and then we're gonna do an exercise together where we implement the what's called the comparable interface for the circle class, which I think I posted online. And so I'm going to stop sharing this. And then I'm going to share the screen again. I'm going to go back to the PowerPoint slides. Yeah. Okay, so first we completed our preliminary discussion, and then okay, so now here, this is why I want us to one of the most widely used interfaces. This is why I want us to study interface, just so we can talk about this. And there's something called comparable, and also it uses generics, which is why we had to talk about generics last week. And so you remember, see how that the bracket T, so public interface comparable. So the interface will only so instead of class, we have public interface, and all it does is it defines a method name. And its input is something of type T, and it returns an integer. And if you remember from last week, I know it's a while ago, it was like a week, yeah, it's a week ago, that T is a generic variable. So when we use the comparable interface, we'll actually pass a class name. T is a variable that represents a class name. And so I'm almost at the end of this. Is this right? Yes. Okay. So I'm gonna, yeah. So we're gonna do that exercise that I have right there. Okay. So and so do I have let me just jump down to the bottom to show you the rules. So the comparable interface it's a little bit weird here, students. We're going to compare two objects with this compare to method, and we're going to return an integer. And here are the rules. These are rules that just were given to us. Let's say object 1 dot compared to object 2 returns a positive number. It means that object 1 is greater than object 2. And if let's say that it returns 0, it means they're equal. And if it returns a negative number, it means object 1 is less than object 2. Okay, and so let's just look at this exercise. I think I wrote it up, the answer in the notes, but let's just try this. Okay, so so a compare to method, basically, let's just look at this. This is the code I'm gonna, might as well look at this, and we'll type this up. Okay, so here's a class. My circle class online is more detailed than this. But see how it says public class circle implements comparable, and then in the brackets I have circle. In the diamond operator I have circle. Okay, whatever in that diamond operator has to be the same parameter type in the compare to. And basically all we're saying is that we're comparing circle objects to circle objects. And I've never seen it when the class name has been different than what's inside the diamond operator. I guess theoretically you can compare circle objects to person objects, but let's go back to the definition of the interface. Remember, these two match. Inside the diamond operator is a T, and the parameter type is of T. So you have to pass a class name. So all this is saying here is in the diamond operator, you put in the class name. We're going to compare circle objects to circle objects. So the input to compare to is going to be a circle object. And remember, students, if this returns, so look at, what are we doing? We're taking the difference of two radiuses. The radius is defined as an integer, right? Right here, private radius. So when you take the difference of two radiuses, you're going to get an integer back. So basically, I'm saying, is this going to be, we wanted to just compare to, return positive, return 0 or negative. And so this represents I might go into Eclipse just to show you this, but this is actually the outer. this refers to the calling object. So OBJ, like whatever on the to the left of the period, that's always the this. That's the current object, and the input parameter is going to be the OBJ2 would be like the input parameter C. So what it's saying is, if the calling circle object has a bigger radius than the input parameter, then you're going to get a positive value, right? This is positive if this dot radius is greater than C dot radius. So the compare two methods that I ask you to write are really just one line. You're taking the difference of two integers. Okay, so let's go back. So let's go look at the actual example itself, unless they're going to stop sharing. So let's just actually look at the, let's try an example here. I know it's hard to do this. I've taught this in class lots of times, and it's hard at the beginning. Okay, so I have a circle class, and then and I thought I had, is this my, oh, and here's my test circle right here. Okay, I wonder if I put the test circle up. Okay. Okay, so let's just run this first. So my circle class is more detailed than the one that I just showed you in the node. So it has two constructors. So the second constructor, the one on line 10, did I share the screen? Am I sharing the screen? No, I didn't share the screen. That should be better, I hope. Here's my circle class. So notice I have two constructors, and the second constructor, the one with no parameters, calls the first constructor, just passes a 1 to it. And then we have get radius and set radius, and we have a toString method which displays the radius. And then hopefully the famous equals method. And I don't have this doesn't implement compare to yet, but it does have this toString. And so let's look at test circle, and and I have a bunch of circle objects. And I have a bunch of circle objects there. And so now I'm just going to display the result of the toString method. So if I just put a variable name in there, that's the equivalent of c.toString. So we're going to print out this isn't formatted very well, is it? Okay, so let's just run this. And you're going to see it's just going to print them out in order. Maybe I can go like this. Let's show you. Oh no, I don't have the shoot. What if I can just go like, no, nothing. Okay, that's not good. Okay, but anyway, we print out the radiuses in order in which they were declared. So students, now we're going to do something really very exciting. And now we're almost at the highlight of today's class. So what we're going to do now is implements. I'm going to say, and I'm going to put the method at the top just so we don't have to go all the way down to the bottom of the file. Implements comparable. And we don't actually write our own, the comparable interface is built in, implements go. It's built into when we install the Java development kit, we get the comparable interface. We actually get a file called comparable.java. And so I notice I'm getting a compiler error now. It says we haven't implemented compare to. Because remember, comparable defines one method. I would never normally write it like this, but I'm going to write it right at the top. And so the first thing I'm going to do here, so public, I can spell, and it returns an integer, compare to, and so whatever in the diamond operator, we put right here, and the parameter name doesn't matter, we'll call it C, and we want to return an integer. And so let's do the one in the slide, so return this dot, I could just put radius, but I'll put this dot radius minus. So this is the outer object, and the C represents what you put inside you pass as an argument to the method. And now notice that that error went away because we implemented the interface. And now let's go to test circle. First, so let's just, I'm going to do one thing here. Let's just print out, let me just, to see this. Okay, so we created this array of circle objects. So let's just first print out, okay. Okay, so the first circle object has radius 80, and the second one has radius 4. So let's just print out the result of their. If I go like this, okay, so circle ARR of 0 dot compare to. It should return 76. It should just be taking the difference of the radius. And it should, so we should get 80 minus 4, because that's what, right? Because that's, so array element 0 represents this, and the first and array element 1 represents the C. So we're just taking the difference, and so let's just try that, and let's see if we get 76. It flew by. Okay, so yeah, and I didn't do that. Okay, so that would mean that the circle object with 80 is greater than the circle object whose radius is 4, because it returns a positive value. Okay, so see how this has no input? That means that the radius is automatically 1. Okay, so let's just do one more. Let's just change the order. Now we should get a negative number. Let's just put a 1 here and a 0 here. So now we should get 4 minus 80. We're just subtracting the difference of the radii. Yeah, you get negative 76. So the second time you get a negative number, which means the circle whose radius is 4 is a smaller circle object than the circle whose radius is 80. And since one thing I want to emphasize, we decide what's bigger and less than. We make up the rules, okay? So it might be intuitive to think, oh, the bigger the radius, the bigger the object, but we'll do 2 examples here. So I'm gonna go back here and just comment this out. So let's go back here. We're gonna print out, hello. I'm having a hard time here. No, that was not what I wanted to do. Okay. Maybe I'll have to do this by hand. Okay, so we're going to print out, first we're going to print this out in order. Now, so there's actually a method, a built-in method called sort. Let's format this. And there's a built-in sort method. It's called arrays. I might need to do a java.util. And what's the name of our circle array? It's called circle ARR. And I'm pretty sure it's going to want java.util.array. So let's import that. Okay, and so this is a built-in method. Arrays is a built-in class with the Java development kit. It has this method called sort. And what it does, it sorts the array based on the rules in our compare to method. So what's the smallest, and it's going to do smallest to largest. So the smallest is this one circle. If you don't have any input parameter, it's automatically 1. And what would be, so it'd be like 1, 4, 6, 33, 55, 80. So let's sort it, and then we'll just print it again this second time after we sort. Then we'll print a blank line too. Okay, so it's good. This sort method uses our comparative. Okay, so let me just. And you can see that it does, originally, it wasn't in sorted order. It was like 80, it was in the order in which I defined them. Then we called the sort method. And now it's one, the radiuses are in order. And it was based on, and it used our rule. Okay, any questions on that, students? So that built-in sort method uses our rule. Now, what I wanted to do, okay, now let's rewrite the compare to method. Let's make, okay, here the smallest radius, the circle with the smallest radius was considered to be the smallest circle object. So if I was, so normally when you like sort things from smallest to largest, you're going to line them up. The left side would be the smallest, and the right side would be the greatest. So now let's sort them so that the largest radius would be considered the small. So if I was going to put the smallest on the left and the largest on the right, the circle object of 80 would be considered the smallest object. So remember, that's what sort does. It sorts from smallest to largest. So let's go into our circle class, and it's real easy to change. Okay, so in this case, we'll just go c.radius. And students, if you're writing a compare to method in my class, it should really just be one line. If it isn't, maybe it's possible you're making it too complicated. Okay, so I just changed the order. It's the radius of the input argument is, the radius of the calling object is being subtracted from the radius of the input argument. So now, so let's just look at this again. So let's first of all, let's so now let's just do these print lines again. Okay, so now let's just print out okay, so now let's just print out the result of the compare to, and it should be different now. Now it should be minus 76, and now it should be positive 76, right? Because what happened when you go circle 0 compared to, so we didn't change what was the outer object and what was the inner object, but now what we're doing is, remember, we're going c dot radius minus this. We changed our compare to. So it's c dot radius minus this dot radius. So in this case, it would be 4 minus 80. Okay, so the first one, so circle AR0 compared to circle AR1 returns negative. That means that the circle object of radius 80, because it's negative, so when we return a negative, the calling object is less than the input argument. Okay, so that means the circle of radius 80 is less than the circle of radius 4. And it's all because of us. We decide the rules, students. Okay, so now I'm going to comment this out. Let's see, can I do this? Can I do this fast? Yes, okay. Let's just comment this out. So now we're going to do the same thing again, students. We're going to display the object in the original order, and now we're going to do the new sorted order. And now it should go largest to smallest instead of smallest to largest. So let's, again, we still have the same order. Okay, so 80 was the first, first we display the order in which they're defined. Then we call arrays.sort, they're on line 22, and uses whatever it uses our rule. It's looking at our compare to method. And what it does is, okay, so now it's being listed from smallest circle to largest circle. But now, the larger the radius, the smaller the circle object. It's kind of counterintuitive, okay? Or the radiuses are now appearing in descending order. You see, because so the circle with radius 80 is considered the smallest. The last one printed, the last one in the array is the largest, and so the circle with radius 1 is now the largest. It's all because of how we define that compare to. So we can define. So I'll give you some. So the next assignment will probably be some exercises with just implementing compare to. It shouldn't be that hard. And I'll also put up more examples too. So this is kind of a simple example. Um, but and I'll put up some more examples probably tomorrow, and also then put up an assignment for you on this weekend. And let me just stop sharing. And then I also, maybe I'll suggest that you read, not actually do any of the exercises, but just suggest you read the section on binary search in the ZyBook. But are there any questions right now? So at the beginning, we talked about the quiz. I'm going to just maybe review the quiz one more time and then post it online. Again, just make sure you review how to write it. You know, basically, all I'm asking you to do is write the kind of classes you wrote at the end of Math 130. You know, just to use super to call a constructor in the parent class, call this to call a constructor in the same class, write an equals method, write a two-string method, be able to override them. And then just write those loops where you're not calling math.pow. We're trying to minimize the number of multiplications in each iteration. So are there any questions from anybody? Okay, so I'm going to stay here until nobody has any questions. So if you do any questions, just unmute or you can chat.
Hey, Professor, I have a question.
Yeah, go ahead.
So you want us to just review like creating a class like we did in Math 130, is that what you said?
You mean for the quiz? Yeah, so I put a file. Yeah, I'm going to post I'll do it faster than I have. But you know what happens? I post these first I have to convert it. It's not really that hard. There's just a lot of little steps. I convert it to an MP4 and then I upload it to YouTube because YouTube will do the closed captioning for me. And that's probably the slowest part. That takes about an hour. But I don't want to post anything that isn't closed caption. So it takes about, just to prepare, it takes a little bit of time. And then I forget, I have to admit. But if there's, don't hesitate to remind me. I don't mind reminders at all. Usually helps. But I'll do that right now. I'll start that. But okay, going back to the quiz. Yes, you're going to do if you read that topics for quiz 3, I think it pretty much tells you exactly what you have to do. And then just review the student and I put up my solution for the last programming assignment. So I'm not going to ask you to write any methods like get highest and get highest grade or get average grade or anything like that. The only methods would be equals and two-string. So you want to write it equals and two-string in the parent class and the child class. You want to be able to override, you'll be able to want to write constructors like that uses super to call a constructor in the parent class and this to call a constructor in the same class. Does that help, Ruben, or does that? That's pretty much.
Yeah.
Okay. Anybody else?
Yeah, so then you said to review, you said searching and algorithm analysis on ZyBooks?
No, I'll post it. That's not, you don't need that for your quiz. Okay, so for the quiz, it's just that writing the class, and then if you read that, everything is in that document. Then you're going to write a couple of like 3 loops for me. You're going to write 2 classes and write 3 loops. And then next week, what we're going to do is we're going to start binary search. We're going to start the searching algorithm, and then I think they get into like order of operations and just trying to measure the number of operations we do to implement an algorithm. So, but I'll put that up as like a suggested reading assignment, but I'm not going to put a ZyBook. You won't get a ZyBook assignment until next week.
All right, sounds good. That pretty much covers everything I had. Thank you.
Then I'll put a programming assignment up this weekend where you implement the comparable interface. So, anybody else?
Yeah, will you be posting this thing up? Because the interface was kind of like, I didn't quite get it. So I guess I'm just going to read up on the Java textbook that I have and just try to go over it.
I'll tell you about the interfaces. So in some ways, I think it's hard because it's so simple. Like if you read it, like you can go into a Java book about interfaces. It's like 1 page, or maybe it's not even 1 page. Some of these Java books are so funny. It's like, oh, here it is. It's like 1 paragraph. It's like, what? It's kind of hard material, but there's not necessarily a lot to say about it because it is so simple. You go public interface, you give the interface a name, like you give a class a name, and then you just list a method name. And that's how you write an interface. And then implementing it, you just say implements, you go public class, whatever, implements the interface, and then you just make sure you write the methods that were in the interface. So in some ways it's simple. The thing that's interesting about interface is we all have to agree to use the same interface. It's kind of like, like I'm holding a pen in my hand. It's like we all agree to call this pen. Like here, like, or maybe whatever country you're in. If you're not, if you're in France or, Spain, you call it something different. But if if you're speaking like English, we call it pen. If you're speaking another language, you call it something else. But if you're speaking English, we all agree to call this pen. Let's say you had your own, let's say everybody had their own word for what it is that I'm holding in my hand. It would be really hard to communicate with each other. So it's this agreement we have to just to make certain things in common. And so we've made this agreement. Basically, the agreement's been made for us that when we compare objects, we're going to use a method called compare to. And so interfaces just imposes this behavior on all these classes. So it's kind of subtle. So hopefully that helps. Hopefully as you do it more, you'll understand it better. But it's not
Yeah,
easy.
because
I don't think
what
it's
was
easy to do. I think
that? Okay.
polymorphism and
Yeah, because I
interface.
know the whole creating class thing. Like, I'm sorry. Go ahead.
Oh, go ahead.
Oh, I was just saying because the whole like creating a class thing. To be honest, that kind of kicked my butt. But I tried as hard as I could, and I did as much as I could for that. But it was because like I told you before, my other teacher, when we got the classes, I think she kind of just like ran through it really fast. But it was because of the whole like the COVID-19 thing and going online. It was crazy, but yeah, it was pretty all right.
I can put some other examples up too, but finding information how to write a class, I think I put a person and a my person class up too. But if you want to, are you still there, Ruben?
Yeah, I'm still here.
Yeah, I can't see you anymore. If you want to, show me an example of just writing a class and mail it to me, you might, and I can give you some feedback before you start the quiz.
Yeah, that'd be great.
I'll see
Do
if I can
you
tell
should
them
I
how to.
just
Oh, go ahead. What were you saying?
so what kind of class should I write? Just kind of like anything, or do you want to like put up like a little
Person class.
challenge?
You can try writing a person class from, that's like the most famous class in the world, a person class. See if you can write that from
Okay.
scratch. Like usually the instance variables are first name, last name, and age.
Okay, sounds good.
Okay.
Yeah, I'll try then I'll send it over your way, and then you can let me know what's going
Okay.
on.
Okay. Anything else?
No, sir. That'll be all. Thank you.
Okay. I'll see you next time. I'm gonna stop there. I'm gonna stop
Sounds
this.
good.